Okay, here is to what could very likely be your last algebra video of the year. I know you guys are sad, but it's the truth. Okay, so solving radical equations. So what are we going to be doing? We're going to be solving equations that involve radicals in them. So let's look at some examples. Here's the first one. 10 equals the square root of 2x. We're wanting to solve for x, okay? X right now is inside a square root symbol. So I want you to ask yourself, how do you get rid of the square root symbol? What's the opposite of the square root? Squaring something. So I'm going to square both sides of my equation so that I can get rid of the square root sign. 10 squared is 100. So 100 is equal to 2x. Okay, the square and the square root cancel each other. So now this is just a one-step equation that we are solving for x. Divide each side by 2 and get x equals 50. Let's look at the next one. Before you can square root, or before you would square each side, what would be the best thing to do? Get x by itself. Get the square root of x by itself. So we're going to add 4 to each side. So I have the square root of x is equal to 9. Now I'm to the point where I can square each side so that I can get my square and square root to cancel. And I get that x, whoops, I forgot to write it there, x is equal to 9 squared, which is 81. All right, what do you think I need to do first here? I'm going to need to subtract 6 to each side first because you're trying to isolate the square root first, okay? You want to get the square root all by itself. So after I subtract 6 to each side, I'm left with this. Now, how do I get the x out from underneath the square root sign? I have to square each side. What I do to the left side, I'd have to do to the right. This square and this square root cancel each other. So I have 5x plus 1 is equal to 16. Now I subtract 1 from each side and get that 5x equals 15, so x equals 3. You can always plug this right back into the problem to check your answer. You should, when you do that, get the exact same thing, 10 equals 10 if you did it right. Okay, let's go ahead and try this one. I'm trying to get x all by itself. So I'm going to, right now, 4 is being multiplied by the square root of x. So what's the opposite of multiplying? I want to divide each side by 4. Okay, so those cancel, and I'm left with the square root of x is equal to 8. Now what do? I square each side. X equals 64. All right, let's look at the next one. Right now, the square root of x is being divided by 2. So the opposite of that would be multiply each side by 2. So I get 12 equals the square root of x. Now what? Square each side. So I get 12 squared, which is 144, is equal to x after those things cancel each other. All right, we have 3 left. Here I have the square root equals a square root. So how do I get rid of the square root? Square. I'm going to square both sides. Square the left, square the right. When I do that, I'm left with 2x minus 1 equals x plus 7. Now you're just solving this for x. You're needing to get the variables onto one side. Okay, so when I work this all out, I'm going to get x equals 8. Next one. What should I do first? I have 2 square roots that are on the same side of the equal sign. So first thing, I'm going to move the other square root over so that I can work this problem just like I did the last one, okay? So I'm going to get, whoops, that should have been a 6 right there, not an x. Okay, so that's a 6. Now I'm going to square each side here. So I get 5x minus 4 is equal to 6, because the square and the square root are canceling each other. Add 4. I get 5x equals 10. So x is equal to 2. Last one, guys. Last example of the last video. Dramatic. Okay, so we are subtracting 12. We're trying to get the square root all by itself. 6 minus 12 gives me negative 6. Now I am going to square each side. So then I get that 6x is equal to, what's negative 6 squared? 36. Divide each side by 6. So x is equal to 6. Something is wrong here. Okay guys, so this last one is a little weird, and this brings up a really good point, something that we need to talk about. When I worked this out, I knew that this negative here was going to give me a little bit of potential problems here. When I was squaring a negative, this 6 minus 12 is negative 6. I ended up getting an answer of x equals 6, but when I plug this back in here, I get 12 plus the square root of 6 times 6. Does that equal 6? So I have 12 plus, this is the square root of 36. The square root of 36 is 6. 12 plus 6 is equal to 18, which is not 6. So this problem right here actually has no solution, okay? No solution to this problem. X equals 6 is wrong. This is what we call an extraneous solution. And that's what happens sometimes when working with these radical expressions. You end up getting a solution that is not true. It's extraneous, okay? So when that occurred, you want to say that there is no solution. So it is very, very important. What this last example just proved to you is that it is very important to check your answers. So what we should have done, if I didn't want to make this video 12, 15 minutes, I would have checked each one. But for your sake, I didn't. So please, when you're working through the problems, plug the solution back into the original problem and verify that the left-hand side equals the right-hand side and that the number that you are circling as your solution really is, in fact, your solution. Okay, that's it.